This is our mechanical design 2, project number 2, Gearbox design. My name is Edgar English. This is Juan and Mikail. So our problem statement for this project was we had to create a gearbox design that has to give off 8 horsepower with an input shaft rotational speed of 1500 and an output of 125, as well as an opposite input-output direction ratio. We had to choose real gears from 3 different gear catalogs, and we had to make sure AGMA design criteria was also accounted for. So our proposed design, we came up with a 9-gear design, as you will see later on in our presentation, and we selected the Boston Gear catalog as our main focus for our equation as well as our gears.
So the way we selected the gears is that we have a specific torque, a specific horsepower that was given to us on the problem statement, and we look at the horsepower and the torque for each specific gear. Or rotational speed was said to be 1500 RPM, so it was a value somewhere in between these two columns, which are the 1200 and the 1800 RPM references. So we had to do an interpolation to find the value for our rotational speed, and then select the gears from there.
So, as Edgar mentioned, we use the Boston Gear catalog. More specifically, we use spur gears. Here you can see that it was a 9-gear system, and it's a combination of both steel and cast iron, with 4 gears being steel and 5 being cast iron. Here you can also see the face, the diameter pitch, the diameters, and of course the number of teeth. This here is our gear analysis, again taken from the Boston Gear catalog. Here you can see the velocity, the transmitted load, the torque, the maximum torque, etc. So, after using the Boston Gear catalog, calculations we use from the textbook, where we perform both bending and wear analysis. From here, as compared to the Boston Gear catalog, you can see through the bending, the values weren't that far off. They were pretty close, but for the wear, they were somewhat off. These minor discrepancies can be a result of few things, as reading values off a graph wrong. It could have been a calculation error, but when you look at the values we received, you can see they're somewhat consistent and kept the same path as the Boston Gear catalog.
We also had to look at the bearings that we're going to use for our gearbox, and we were given, in the Boston Gear catalog, we were also given the maximum amount of load that one bearing can support. So we look at those loads, and we found that the load for each of the gears, and based on that we selected 3 different bearings, and those differences are mainly on the board for the bearing to fit on the shaft. So, and those are the values that we have for our bearings. And we came out with this. This is our final design. We have 9 different gears in a box that is as compact as possible. We wanted to have an input and output shaft that were kind of in the same position on the opposite side of the box. Our input will be coming in this side, and this will be the output shaft on this side. Go ahead. So, in conclusion, we were able to find the correct amount of gears and the selection of gears that will perform to our design characteristics, which were 8 horsepower and an input of 1500 revolutions per minute and an output of 125 revolutions per minute. We were also able to apply the AGMA procedures to make sure that our gearing system supports the loadings that the system is going to be working on, and everything was very successful. Thank you so much for
Thank you.
everything.